All right, thank you so much. Actually, I want to take this opportunity to thank Amazon for giving us, all of us partners, a great opportunity to be here and present. Okay, so I am in product management at MapR Technologies. I'm Susie Vishwanathan. For those of you who have not heard about MapR Technologies, we are prominent in the big data world. We have a great story around AI and ML, and we have been growing quite significantly, especially in the past 4 or 5 years. Actually, this is a great spot we have because if you had been following all the talks by the other vendors, they talked about network, yes, and then they talked about security. So then there is a third big piece, which is nothing but your platform. So folks, especially our customers, we have customers who are ranging in a few petabytes of data and then several hundreds of petabytes all running on MapR clusters. So MapR can be run on an on-premise data center, but it is also predominantly known to be running in public clouds as well, especially Amazon. So when you run containers, the biggest thing that you can, if you Google, you'll get a litany of information around persistent data, how do you scale, what is the security aspect of it, network aspect of it. And like I mentioned, you saw one vendor talk about the network aspect, you saw another vendor talk about the security aspect. Now let's talk about everything else. Let's talk about scale, let's talk about persistence. So MapR is very good at that, basically because our underlying foundation is nothing but a distributed platform. It's a distributed file system. There are customers who run the entire big data ecosystem on us. There are customers who run Spark on us, Kafka, Hive, you name it, we are there. So what we have today is, I could just talk about MapR all day long, right? But we have several portfolios on our platform. But what we have today is show you how we have integrated with Amazon, how we have integrated with EKS to give you a holistic end-to-end solutions. If you're running containers in Amazon, you will see how you can leverage the scalable aspect to grow your data or to just deploy and store your data with MapR augmenting with Amazon. This James here, my colleague, has a really cool, nifty demo for you guys to show. And post that, since we all have just a limited amount of time, I would be more than glad to talk to you if you have any questions or even continue discussions later on. So with that, I'll hand it over to James.
Thank you very much, Susie. My name is James Sung. I'm a solution architect from MapR. So today I'm just going to show you a very simple demo to demonstrate how EKS can integrate with MapR. So the demo I'm going to use today is the New York City Bike share program. I'm sure they have something here in the city too, but I just couldn't find any information where they publish the raw JSONs to the internet where we can just grab it for free. So I'm just using New York City Bike because they publish the JSON, raw JSON, out in the internet, and I can grab it. So here you can see in this architecture, actually there are 3 containers orchestrated by EKS. And then we spin up a MapR sandbox, which is just one node. By the way, MapR is already in AWS Marketplace, so it's very easy for you to spin up either a sandbox for experiment, or you can spin up a full-blown MapR cluster very easily. Right? So this architecture gives you a very good way to decouple the compute and the storage, right? So if you run out of compute, you can add more EKS nodes, workers, to catch up with your compute demand. If you run out of storage capacity, you can add more MapR nodes, and it's very easy to do. So that way you can scale your infrastructure independently, either with storage or with compute. All right, so we got a container on the left there. That's grabbing the raw JSON from the City Bike site. And then from there, it kind of tees off One going to the top path where it's more real time. Imagine if you are a city planner for New York City, you will want to know what's the status of all the bike stations throughout the city. And on the other hand, you probably need to know if I want to look back 3 months or 6 months, right? How my bike station are doing. Are they constantly out of capacity, or maybe I need to add more bikes at this station and move some bikes around. So it's good for a analyst to look at the historically and also do something more real-time fashion. Okay, so MapR provides the volumes. One for doing the real-time analysis, right? So we are using the InfluxDB, which is a time series database, and to the container, the InfluxDB container itself, it's just like a mount point, right? Just MySQL or Oracle, just a mount point, so you can write data to it. On the other hand, if you want to dump all your JSONs into a, say, container, we can provide a volume, and you dump all your unstructured data there. And what's good about this is once it's inside of MapR, you can use your favorite tool like Spark or Hive Drill to do your queries and machine learning, AI. You don't need to actually migrate your data out of your MapR, your cluster to a Hadoop-aware cluster to do your Spark or machine learning there. So our customers like that a lot, right? Everything right in the same place. And not only that, we also provide the capability of doing snapshots as well as remote mirroring to remote data centers, so you can protect your data if you have some sort of a DR policy in place, okay? So this is the overall architecture for the demo. And then let's dive into the dashboard, see what's going on inside Kubernetes. So here you can see immediately we have a storage class defined. Oh, sorry, I need to log in here. It times out already. Okay, so you can see there is a storage class. And here, you define the storage class where you tell it, how to communicate with MapR and the quota and everything, right? So, and the ticket is secure. We are using MapR ticket to secure the communication between the storage and EKS. And once you have the storage class defined, you are going to create some sort of persistent volume claims. And let's change to a different namespace here. So here you see you have two persistent volume claims. One is for the real-time InfluxDB database you saw earlier, and the other one is for the container to accept all the raw JSONs. So these are the storage volume claims. And here you can define you want it in read-only mode or read-write mode. Everything is defined here. Once you have that, let's go ahead and go to the pods itself. So we got 3 pods here. And then if you go inside of, say, this one is the container on the left side that's grabbing all the JSON file. Let's go into it and see what's going on. So if you do a mount command and grab for, you can see this MapR volume is mounted under /cdbike, and if you go into it, you can see all the JSON files right here. So it's continuously capturing all the raw JSONs, and the JSON files contains the stats from each location throughout the city. Sorry, I couldn't see what I'm actually typing here. But yeah, so if you do a cat of these JSON file, you will see it's got all kind of information for each bike stations. So now let's go back to the other one that's hosting the InfluxDB database. And this one is mounted under here. So you can see it's a bit more structured compared to the raw volumes, right? Like MySQL, you have the metadata directory as well as the the log, write ahead log directory, and then the data itself, right? So this is serving the InfluxDB database. Okay. So when you try to mount the MapR volumes, you talk to EKS, and EKS will go find the definition inside of your storage class, and then it will kick off a provisioner, which is running as a container inside of different namespace. I'm not showing here, but that container will provision the MapR volumes accordingly and give it to the containers in EKS to be able to mount. So that's the whole idea. So now let's take a look at the final product here. So I'm using a Grafana open source UI program. And here you can select your own bike station number. And you can see for the past maybe 24 hours how the demand looks like, right? You can see the ebb and flow of these for this bike station, right, throughout the past 24 hours. And here you can see available bikes, and also have a global view of where the bike stations are, and are they currently low in capacity, or they are okay, doing okay, right? So finally, I want to show you on the other volume, you have the raw JSON, right? So Apache Drill is a Hadoop. Well, it's a SQL on Hadoop solution where you can define your storage plugin. And here we have a JSON storage plugin. So you can run your favorite query in SQL. This one very simple. You can point it at the volume, which is a directory, in the Hadoop or MapR file system, right? So you can just submit, and it shows you all the raw data there. And of course, you can do your join and other fancy queries to be able to join with data format that's defined by a different drill storage plugin, for example, CSV. We are working on the Kafka format storage plugin. So check it out on drill.apache.org. There's a lot of information there. So this concludes my demonstration today. Thank you very much.
Thank you.